This is a new product line for Microchip that complements our microcontroller offerings. In many applications, random access memory, or RAM, is required for various types of temporary memory. While virtually all microcontrollers contain some RAM, serial SRAM represents a simple way to add additional RAM to an application. Our two new device families, the 23X640 and 23X256 parts, can add 8 or 32 KB of external RAM to an application. These parts use a standard SPI interface that requires only 4 IOs, and they're available in small 8-pin packages. In this webinar, I'll talk about how serial SRAM can give you design flexibility, improve your time to market, and reduce costs. So is RAM expansion using serial SRAM an interesting proposition for your designs? Here are some questions to think about while we go through the presentation. First, do you simply need more RAM for your application? Second, are you performing RAM-intensive functions like math algorithms, data buffering, or audio-video applications that need large amounts of temporary storage? One solution to these problems is to buy a larger micro with more RAM, but that can result in a more expensive design and a longer time to market. Is that acceptable? Another solution would be to add additional parallel RAM, but this means a large package size as well as requiring more microcontroller IOs and additional PCB routing. Serial SRAM products can solve these issues. The rest of this web seminar will build on these ideas. Now let's look at our agenda. If you usually think in terms of kbytes, this works out to 8 and 32 kbytes respectively. To give you a sense of scale, compare these densities to a typical 8-bit microcontroller that has a maximum of 4 to 8 kbytes of onboard RAM. You can dramatically increase the amount of RAM by using serial SRAM. Second, the devices operate at bus speeds up to 20 MHz, making for very fast data transfer. The devices are available in 1.8 and 3 volt options. Both options have operating temperatures of -40 to 125 degrees C. The devices have very low current consumption, making them excellent for battery and other low-power applications. Maximum standby current is only 4 microamps. The parts can operate in 3 modes as specified in the status register. Word mode, where data is read to or written from a specific word address. Page mode, where data is transferred to or from a 32-byte page. And sequential mode, in which the entire chip can be accessed with a single command. To understand the advantages of serial SRAM, let's assume an application that requires a large amount of RAM. The easiest way to get it, of course, is to use a micro with RAM on board. As I mentioned earlier, even high-end 8-bit micros have less than 8 kbytes of RAM, and most use much less. What if you need more? Or, what if you want to increase the functionality of a current design, but you need more RAM to do it? What are your options? First, you could buy a larger micro. But since there are limited RAM options in most micros, this probably means a more expensive device. And if you are only buying a larger micro to get the extra RAM, you're also probably paying for extra features that you don't need. And a larger micro also requires more board space. Your next option is to use off-chip memory, most commonly parallel RAM. You can certainly get a wide range of densities, up to 128 megabits, and, being parallel, it is very fast. But traditional RAM has its own disadvantages. First, the packages are large, at least 28 pins and often 44, and can be expensive. These large packages take up a good deal of board space. And the parallel interface for a 32 kbyte RAM chip requires an external address and data bus using 16 to 24 I/O pins. These pins may not be available on your current microcontroller. Finally, parallel RAM typically has fairly high standby current consumption. Microchip now provides serial SRAM, which represents another way to introduce off-chip RAM into a design. The connection to the micro is the classic SPI interface, which is well understood and easy to design with, especially since many micros already have an SPI interface port. As shown here, it only requires 4 I/O pins. It is very easy to add up to 32 kbytes to a design with one small 8-lead SOIC or TSSOP package. And remember that serial SRAM is very well suited to embedded designs due to its very low standby current. In applications that don't need a lot of processing power and can use a small to mid-sized micro, or in applications that require a lot of RAM, serial SRAM can be a good option to keep costs down and to get to market faster. Microchip gives its customers flexible design options. We have micros with many RAM options, and now we offer external serial SRAM as another option. So the advantages of serial SRAM include flexibility, time to market, and reduced system cost. I'll expand on those points in the next slide as we look at an actual application. Much more information available on our website. For specific product information, see our datasheets and app notes, most with code. We also have a second webinar with its accompanying app note, AN 1245, that describes some recommended usages for serial SRAM devices. For more information on the Internet Radio, see our app note AN 1128. And you can buy this reference design on our website. We have a fully stocked sample inventory of these devices. You can order samples and even production quantities from our website. All these can be found on our SRAM homepage at www.microchip.com/SRAM. And that completes this web seminar on serial SRAM. I'd like to summarize the important benefits of this new product line. First, serial SRAM gives designers a way to expand the available RAM in an application. You can add up to 32 kbytes of SRAM in a small 8-lead package. This is great for applications that require a lot of memory, as we saw in the Internet Radio application, and data-intensive algorithms. Using a serial SRAM can decrease your time to market and help to keep costs down, since you can add RAM to an existing micro design. And the SRAM parts use the very familiar SPI interface, which makes for quick, easy designs using just 4 I/Os. Finally, the serial SRAM products have excellent performance characteristics. The parts run up to 20 MHz. And since data is written directly to the array with no interruptions for write cycles, data can be written very quickly into the devices. In fact, you can write the entire 32 kbyte memory in only 13 milliseconds. The devices use volatile cell technology, so the array can be written an infinite number of times. And finally, the parts have been designed with the embedded market in mind and have very low power characteristics.